Okay, here's some quick explanation to help with the PS time for 7-1. The first problem, you've got this satellite that's orbiting, and it gives you some equation like this, and they want to know when it's 1,000 miles north. A couple things to help you figure this out. I'm not going to show you the whole answer or all the mechanics. This is just a quick explanation video. First of all, when they give you pi as part of the period calculation, put your calculator in radians. That's what a lot of students were messing up yesterday, so make sure you have a little R right there. And then when you put the 1,000 right there, and again, just like I said in class, you have to do inverse operations, okay? So divide the 3,000 over to the left-hand side. 1,000 divided by 3,000 is this 1/3. And then you do cosine inverse of 1/3 is going to equal this stuff. That's how we get rid of the cosine. Okay? Now that gives us these two values, and you might be asking yourself, why did we get those two values? Let me show you the whole thing. So when you plug in cosine inverse of 1/3, it gives you 1.23. But you have to remember that cosine is positive at two places around the full 2 pi period. So there's about 1.23 radians. By the way, a full pi over 2 radians, just for reference, that's about 1.57 radians. And of course, pi radians is 3.14. 2 pi radians is about 6.28. So the radians around this is 1.23. So there's my cosine for this positive angle, but if I reflect this angle over the x-axis, I have this material or this space on this triangle, which also gives me cosine inverse of 1/3. How do I find the 5.05, you might ask? Well, we use the fact that all the way around the circle is 2 pi radians, so you very simply just plug that straight into your calculator, go 2 times, find the pi button. My pi button's right down there, and I hit that. I've got 2 times pi, then I can subtract 1.23, and boom, I get 5.05 radians for the other angle that has a cosine inverse of 1/3. So now this is how you get the multiple answers. If you do the inverse operations, I'm going to leave that to you for you guys to figure this out. You get 25.62 minutes and 80.37 minutes. But that's not the full answer. As most of you see on this problem, there's 5 answers to get. So you have to remember, hey, we're on the interval from 0 to 240 minutes. How do you have to find the period of this function? Remember, the period is 2 pi over b. This is our b coefficient. So we do this little calculation. Remember, division is multiplying by the reciprocal, and bam, we get 90 minutes. So at this angle right here, if I just add 90 minutes to it, it's going to be at the same place, 1,000 miles north of the equator. Same thing for this angle. If I add 90 minutes to it, it's going to be at the same place. So you do this. There's 2 of the answers. Add 90, add 180 for 2 rotations around past that. I think you'll see that if 80 plus 180, this is going to be 260 something, and that's outside the interval for 240 minutes. So your answer is going to be these 2, and then this one, those 5 answers for whatever those calculate out to be. Okay? Hope that helps.